Welcome to our video. Today we will talk about an interesting topic. Let's start. Our topic is inter-process communication. First we need to know some things to understand the topic well. If we have two processes, process A and process B, and we want them to be synchronized for some reason, then we need to make the two processes communicate with each other. Well, let's get deeper in our topic. We have two types of communication. The first is shared memory, and the second is message passing. We will suppose that I'm process A, and my friend is process B. The box is the shared memory, and I put my data in this box. My friend can take the data from this box. So this is the concept of shared memory. After we covered the concept of shared memory, we will explain the concept of message passing now. We will use the previous example, but we will add my second friend right there. We will suppose that he is the kernel in the system. So I send a message to that box, which is the message queue in this example. The kernel is responsible for organizing the process of sending and receiving the messages, to prevent the synchronization problem that we will talk about later. So after all we said, we haven't know the difference between them yet. I will tell you now. First difference, we need to know that shared memory is used for communication between processes on a single processor or multiprocessor systems, where the communicating processes reside on the same machine. And message passing is typically used in a distributed environment where communicating processes reside on remote machines connected through a network. Shared memory can be faster, since message passing systems are implemented using system calls and thus require the more for kernel intervention. Message passing is useful for exchanging smaller amounts of data, because no conflicts need be avoided. Also, message passing is easier to implement in a distributed system. Well, let's talk about a topic that we mentioned before. This topic is synchronization problem. Synchronization problem is something happens when two processes are not writing to the same location simultaneously. Let me show you how that happens. We will explain one of the most known synchronization problems. It's producer and consumer problem. So we have here two processes, producer and consumer. And we have a shared variable between them, it is counter. So the scenario is that producer produces data in the circular queue and increase the counter, but it can't produce data if the queue is full. The consumer consumes data from the queue and decrease the counter, but it can't consume data if the queue is empty. So when producer produces data, that what happens? And when consumer consumes data, this what happens? So imagine what will happen if the two processes happen concurrently. The counter will respond only with one of them, and this will cause a mistakes in the data. I wish you have benefited from this video. Thank you for listening well.